Morning, guys. Starting chapter 6. The sections that we usually cover in chapter 6 are the law of sines, the law of cosines, and Heron's area formula. And all three of those are kind of lumped together in chapter 6 because they are the first things that we have learned that work on non-right triangles. Okay, so you're going to have triangles that do not have a 90-degree angle in them. And this is the first thing that we've learned the entire semester that you can use on those. Okay, so the law of sines and the law of cosines are going to be used to find missing sides or angles of non-right triangles. Heron's area formula is going to be used to find the area of those triangles. Okay, but they all have that in common, that they can be used on non-right triangles. Okay, this is the formula for the law of sines. Okay, so as you can see, it's a pretty straightforward equation. We have basically, I think of them as pairs. Okay, remember the small a, b, and c are the sides of our triangle, and the large a, b, and c are the angles of our triangle. You are going to be needing a calculator that does a scientific calculator that does sines of angles. And if you don't have one of those, you can find one online. You can put one on your phone, use one on your phone. You want to remember, though, to make sure that your calculator is in degrees before you get started, because in these problems, they will be measured in degrees. And so you want to make sure of that before you start. It's been a while since you had to worry about that, so I wanted to remind you. Okay? Two different cases we're going to go over today. One of them is when you have an angle side, and one of them was when you have an angle side angle. Okay, so this is probably taking you back to geometry days. What is the difference between these two? They both have two angles and they have a side, but the difference is where they're located on the triangle. Okay, so here the two angles that we know are next to each other, and the side that we know is not the side that's in between those two angles. It's one of these sides that's outside of those two. Okay? The second case we're going to do is an angle side angle. And the angle side angle, we also know two angles. Okay? But we know the side that's in between those two angles. And you're really not going to have to worry about this. When I first started teaching this years ago, I used to make a big deal about, well, on angle side angles, you use the law of sines. On this type, you use the law of cosines. In reality, if you have a pair, any of these pairs, you can use the law of sines. So you really don't have to worry a whole bunch about what type of a case it is, what type of a triangle it is. But I just thought I would point that out because your book does discuss it, and maybe it will bring back some fond geometry memories if you have any of those. Okay? All right, so you're going to show me work on how you find these, but they're not always going to be found in the same way, okay? And this is going to be true as we go through everything that we're going to be doing in chapter 6, okay? For angle C, for example, the easiest way to find angle C is basically just using subtraction, isn't it? Because we know that the angles inside of a triangle have to add up to 180, okay? So angle C is going to be 180 minus the sum of 30 plus 45. Okay, so these two add up to 75, and 180 minus 75 is 105 degrees. Okay, so our angle C is 105 degrees. Okay, even though you're just using subtraction, I still need to see that that's what you're doing. Okay, then to find side B. Okay, well, what pair do we know? I said that if we know one of these pairs, we can use this. Which pair do we know where we have a side and we have the angle that's across from it? It's our A's, isn't it? Okay, so we know A over the sine of A. Okay, so 20 over the sine of 30 degrees, that's A over the sine of A, okay, equals B, which we don't know, over the sine of B. Okay, so I'm using this part right here, right now. I can either use this part, I can use this part, I can use these, I can use any two parts or fractions out of this equation. It just depends on what I know and what I'm trying to find. Okay, so to find side B, this makes sense. I know this pair, okay? I don't want to do C next because I found angle C, and I don't want to use that if I don't have to. I may have to later, but I don't want to use it right off the bat. Okay, so I'm going to cross multiply here to solve this. So 20 times the sine of 45 equals B times the sine of 30. Okay, and I'm going to divide both sides by the sine of 30 so that I can get B by itself. Okay, and now I'm just going to put this part into my calculator. Okay, so here I go. I'm in degrees. I'm going to do 20 sine of 45. Enter. Make sure you hit enter or end your parenthesis, one of the two, divided by the sine of 30 degrees. And there we go. 28. I'm going to put a little squiggle on there for approximately equal to, because I'm going to round this off, 28.28. And as we know with our book, it doesn't always do a good job of telling you what place to go when you're rounding. If we were in class taking a quiz or a test, I would be very sure to tell you that. Okay, so you'll notice what the book rounds to, and you'll just do the same thing. Okay? All right, now what's left? Well, a lot of times students will go, well, I think I'm going to use the Pythagorean theorem now. I know two of the sides. I can find the third side. Why can't we use the Pythagorean? Because it's not a right triangle, okay? So we don't want to use that next. We want instead to find side C using the first pair that we knew, okay? 20 over the sine of 30, A over A, okay? But this time I'm going to jump over here and set this equal to C over the sine of C. Okay, C I don't know. The sine of C I did find up here. I'm going to have to use that one now. Okay, and I'm going again to cross multiply. Okay, so 20 times the sine of 105 equals C times the sine of 30. And again, I'm going to divide by the sine of 30. I'm going to go to my calculator. I'm going to do 20 sine of 105, hit enter or end your parenthesis, divided by the sine of 30. Okay, and that gives me C is approximately equal to 38.64. Okay, oh, forgot to put degrees on both of those, and I should. Okay. It's pretty straightforward, okay? One thing I always tell students when we start Chapter 6 is that when you give a quiz or a test in Chapter 6, this is what you will hear in the classroom. That's all you will hear is people pushing buttons, okay? Because it's a highly just calculator type sections that we're doing right here. And you're basically just doing computations. We used to call these when I was in college, plug and chug. Okay, so you may have heard that before. You're going to plug these numbers into the equation and you're just going to do the chugging. Your calculator is going to do the chugging for you. Okay? All right, let's go down to angle, side angle example. Okay? And again, we still know two angles, okay? But we know the side that's in between those two angles. Do we have a pair? Not yet. But we can find angle C by, again, doing subtraction. So angle C is equal to 180 minus 16 plus 98. Okay? And 16 plus 98... oh, wow, my brain is not working real well here today, is 114. And 180 minus 114 is going to be 66 degrees. Okay? Now, to find side B, well, we now know a pair. We know side C, we know angle C, so 8.4 over the sine of C, which is 66 degrees, is equal to B, which we don't know, over the sine of 98. Okay, and again, I'm going to cross multiply. 8.4 times the sine of 98 is equal to B times the sine of 66. Sorry, I'm running out of room here, guys. And I'm going to divide by the sine of 66. Okay, and again, I'm just going to type this in my calculator. 8.4 times the sine of 98, enter, or end your parenthesis, divided by the sine of 66. Okay, so side B is approximately equal to 9.11. Okay, going out 2 places past the decimal or to the hundredths place. Okay, by the way, I've been saying make sure that you enter or end your parenthesis. Let me show you what happens if you don't do that, okay, because this is a very common mistake. Okay, 8.4 sine of 98 divided by the sine of 66. Okay, you're not going to get the same answer, not even close. We got 8.02 compared to 9.11. And the reason for that is when you didn't end this parenthesis, you didn't just divide by the sine of 98, you divided by the sine of 98 divided by the sine of 66. So you want to be really careful that you either end that parenthesis or hit enter. Okay? All right, and then to find angle A, we can again start with the same pair. We'll start with our C's, okay? Because we were given those, we know those are correct. I don't want to use the B's if I can help it because I found that myself and there could be a problem. And if that's a problem, then I'm going to cause another problem, okay? And this is equal to side A over the sine of 16. And again, I'm going to cross multiply. 8.4 times the sine of 16 is equal to A times the sine of 66 and divide by the sine of 66. Okay, so 8.4 sine of 16, parenthesis or enter, divided by the sine of 66. And there we go, 2.53. Okay, and this is basically what I expect to see on your paper. If you use subtraction, show me that. If you use the law of sines, I expect at least to see this proportion. If I don't see this, I'm not too worried about that. Many of you can do that part in your head and using your calculator, obviously. But I do need to see the proportion and your final answer. The proportion and your final answer. Okay? And that's about it. It's pretty straightforward. I think you guys will like this stuff because it's very computational. Okay? So good luck. I will see you guys soon.